Hello, my name is Ardi and we are going to solve problem 3.1 from Brown and Francis's book. So the question is determine the decimal values of the following unsigned numbers. Okay, let's do it one by one. So first we are going to solve problem A. This is in base 2. So let's copy the problem first. We will have 0 and then triple 1. Okay, and then 0 and then 4 ones, 1 2 3 4, and then 0 there. Okay, and that is in base 2. Good. So now let's start from the back here. We have 0 here, so we will have 0, and because the base is in base 2, so 0 multiplied by 2 to the 0. Okay, now let's move on to this one. We will have 1. So we'll have 1, then multiply it by 2 to the 1. Good. We have done this and we have done this. And so let's do another one. So we will have 1, then multiplied by 2 by 2. We have this, and then plus 1, again multiplied by 2 to the 3. Okay, and then this is done, and then this one. Okay, we will have 1, but this time multiplied by 2 to the 4th power. Good. Now let's move it here. So we will have 0, but this time 2 to the 5. Good. And then let's move on here. So we have plus 1 multiplied by 2 to the 6, and then have 1, and that will be multiplied by 2 to the 7, and then here we will have 1 multiplied by 2 to the 8, and then we will have 0 multiplied to the 2 to the 9. Okay, let's simplify things here. I think we will have 0 here. So we will have 0 first. And then plus 1 multiplied by 2 to the 1. That will be 2. Good. And then 1 multiplied by 2 to the 2. That will be 4. And then here 1 multiplied by this is 8, right? So I will have 8 here. And then we will have 1 multiplied by 16. So we'll have 16 here, and then we will have 0. Good. Then we will have this one will be 2 to the 6 is 64. So I will have 64 here. And 2 to the 7 is 128. And then 2 to the 8 is 256. And this one will be 0. Good. I think I'm too lazy to calculate all of this manually. Let's just use calculator. So we'll have 0 plus 2 plus 4 plus 8 plus 16. Then plus 0 plus 64 plus 128, and then plus 256. Okay, we'll have 478. 478. This is the answer for problem A. Let's write that here. So we'll have 478. Good. Now let's move on to problem B. Let's play the same game all over again. So this is base 2. Let's copy the problem first. We'll have 1. 1 and then 0, triple 1, and then double 0, and then triple 1. Okay, and that is in base 2. Remember, we have in base 2, and let's start from the last one, the least significant bit. So we'll have 1, then multiplied by 2 to the 0. Good. And then here we will have 1, multiplied by 2 to the 1. Okay, and then here we will have 1, but then multiplied by 2 to the 2. Good. And the next one will be 0 multiplied by 2 to the 3 here. And then here we will have 0 multiplied by 2 to the 4. And then we will have 1. So we multiply this by 2 to the 5th power. And then we will have 1, 2 to the 6. And then plus 1 multiplied by 2 to the 7. And then 0 multiplied by 2 to the 8. And then finally 1 multiplied by 2 to the 9. Okay, now let's simplify this. I think this will be 1. Okay, and then 1 multiplied by 2, I think we will have 1. And then 1 multiplied by 4, we will have 4 there. And this one is 0. And this also 0. But we get 1 multiplied by this one, so we will have 32. And then we will have 1 multiplied by 2 to the 6, that is 64. And then we will have 1 multiplied by this, we will have 128. And then we will have this one, that is 0. And then this one, 2 to the 9 is 512. Good. And let's just put all of this to calculator. 1 plus 2 plus 4 plus 0 plus 0 plus 32 plus 64 plus 128 plus 0 and plus 512. Good, we have 743. And I think that is the answer for problem B. So let's write that down. And that is for problem B. Okay, good. Now let's move on to problem C. Okay, this time that is not binary, but that is an octal number, which is on base 8. Okay, I think that will be another game, but it is still similar to this one. Okay, so let's rewrite the problem first. We will have 3, 7, 5, 1 on base 8. Okay, let's start from the back. So we will have 1. Okay, remember that we work on base 8 here. So that we multiply it by 8. 8 to the 0 here. And then the second one, I think we will have 5 multiplied by 8 to the 1. Good. And then we will have 7. But this time multiplied by 8 squared. And then 3. We increase the power of the 8. So we will have 8 cubed. Right? I think that's all. Okay, let's calculate that. We will have 1. 8 to the 0 is just 1. Okay, and then 5 to the 8, 5 multiplied by 8 to the 1. So 8 to the 1 is just 8, so I will have 40. But here things start to get rough. So we will have 7 multiplied by 64. And then that one will be 3 multiplied by 8 to the third power. What is 8 to the third power? Okay, 512. Yeah, I think we need to put this into calculator, I think. So we'll have 1 plus 40 plus 7 multiplied by 64 plus 3 multiplied by 512. And we have 2025. Okay, we will have 20 and 25, which is this year when the video is made. If you are in the future, let me know. Okay, that is for problem C. Good, now let's move on to problem D, but this time in base 16. Okay, let's clean up the slide first. Okay, now let's move on to problem D. We will have this number here, but this time in base 16 or hexadecimal, you call it. Let's do that. We will have A 2 5 F, which is in base 16. Okay, let's rewrite that. So we will have F multiplied by 16 to the 0, and then plus 5 multiplied by 16 to the 1, and then we will have 2 multiplied by 16 squared, and then A multiplied by 16 to the 3. Okay, we will have this, but we have a problem here. This is a letter, not a number, so we need to convert that into a number. But remember, in hexadecimal, after 9 we will have A, which is equal to 10, and then B, which is equal to 11, and so on. So C is 12, and then D is 13, E is 14, and then F is 15. Okay, so now let's convert the letter into numbers. Let's do exactly that. F is 15, so 15 multiplied by 16 to the 0. Let's just make it 16. And then we will have 5. 5 is still 5, so 5 multiplied by 16. Oh, no. 16 to the 0 is 1. So we will have 1 here. And then we will have 2 multiplied by 16 squared, which is 256. But A is 10, so we will have 10. But 16 to the third power is hard to calculate. I don't remember actually. So yeah, 4096. Okay, and let's just plug this into calculator, right? 15 multiplied by 1 plus 5 times 16 plus 2 multiplied by 256, then plus 10 multiplied by 4096. Good, I will have 41567. 41567. So this is the answer for problem D. 41567. Good. And now let's solve the last one, which is problem E. We have F0 base 16. Let's clean up the board. Okay, again we work in hexadecimal here. Let's copy the number, the problem first. So we will have F0 on base 16. So let's start from the least significant hexa bit here. So we will have 0 multiplied by 16 to the 0, and then plus F multiplied to the 16 to the 1, and then plus 0 multiplied by 16 squared, and then we will have F multiplied by 16 cubed. Good. 0 multiplied by anything is just 0, and then F is 15 multiplied by 16 here, and then this one will be 0, and we will have 15 multiplied by 4096. Okay, and let's just put that into calculator. We will have 0 plus 15 multiplied by 16 plus 0 plus 15 multiplied by 4096. And we will have that number here. So we will have 61,000. 61,680. So we will have 61 and then 680. And we have answered all the problem here. Hopefully I did not make any mistakes. See you in the next video. Bye bye.